Welcome to Cloud DNS Comparison. Welcome to the channel. Please consider subscribing. I produce videos daily covering cloud solutions with focus on networking. Today, we'll explore AWS Route 53, Azure DNS, and Google Cloud DNS to help you make an informed decision for your cloud infrastructure. DNS is the backbone of internet connectivity, translating human-readable domain names into IP addresses. In the cloud era, managed DNS services have become critical infrastructure components, offering not just name resolution but also traffic management, health checking, and global load balancing. Each cloud provider has developed their DNS service with unique strengths and features. We'll examine these differences to help you choose the right solution for your needs. DNS Architecture Overview. Let me walk you through how DNS works in the cloud environment. Unlike traditional DNS servers that you might manage yourself, cloud DNS services operate on a globally distributed network of name servers. When a user queries your domain, their request hits the nearest DNS server in the provider's network. This server either has the answer cached or queries the authoritative name servers. The beauty of cloud DNS is that this happens across hundreds of points of presence worldwide, ensuring low latency and high availability. Each provider implements this differently. AWS uses Route 53's global Anycast network. Azure leverages its global infrastructure with Azure Traffic Manager integration. And Google uses its massive global network that also powers Google Public DNS. The diagram shows the flow from user query through recursive resolvers to the cloud provider's authoritative DNS servers, and finally to your actual resources. AWS Route 53 Deep Dive. Route 53 is named after TCP, UDP port 53, where DNS server requests are addressed. It's one of AWS's most mature services, launched in 2010, and has evolved into a comprehensive DNS and traffic management solution. What makes Route 53 special is its deep integration with the AWS ecosystem. You can automatically create DNS records for your EC2 instances, load balancers, and CloudFront distributions. The health checking feature can monitor endpoints worldwide and automatically failover traffic. The code example shows how to create a hosted zone and add records using the AWS CLI. Notice how straightforward it is. You specify the zone name, and AWS assigns 4 name servers across different top-level domains for redundancy. One unique aspect is the routing policies. You can implement weighted routing for A/B testing, latency-based routing to send users to the nearest region, or geolocation routing to serve different content based on the user's location. Azure DNS capabilities. Azure DNS might seem like the newcomer, but it's built on Microsoft's decades of experience running massive-scale services. It uses the same global network that powers Office 365 and other Microsoft services. The standout feature is its integration with Azure Traffic Manager. While Azure DNS handles the name resolution, Traffic Manager provides the intelligent routing capabilities. This separation of concerns allows for more flexible architectures. The PowerShell and CLI examples show Azure's approach. It's deeply integrated with Azure Resource Manager. Everything is a resource with a clear hierarchy: subscription, resource group, DNS zone, and record sets. This makes it easy to manage permissions and organize resources. Azure DNS also supports private DNS zones, which are incredibly useful for internal name resolution within your virtual networks. You can have split-brain DNS where the same domain resolves differently internally versus externally. Google Cloud DNS features. Google Cloud DNS leverages the same infrastructure that handles billions of DNS queries for Google's own services. This means incredible scale and reliability are built in from day one. What I find impressive about Cloud DNS is its simplicity. Google has resisted the temptation to add every possible feature, instead focusing on doing DNS really well. The API is clean, the pricing is straightforward, and it just works. The gcloud commands show how you can manage zones and records. Notice the support for importing and exporting bind zone files. This makes migration from traditional DNS servers much easier. Google's approach to private zones is elegant. They're automatically available to all VPCs in your project, but you can also share them across projects. This fits well with Google's organizational hierarchy of organizations, folders, and projects. Feature comparison matrix. Now let's dive into a detailed feature comparison. This matrix highlights where each service excels and where they might fall short for your specific needs. Route 53 leads in routing sophistication with 7 different routing policies. This is unmatched by the others. If you need complex traffic management, Route 53 is your best bet. Azure DNS shines in its integration with the broader Azure ecosystem. The combination with Traffic Manager gives you Route 53-like capabilities, though configured separately. Its support for CAA records and integration with Azure Private Endpoints is excellent. Google Cloud DNS takes the minimalist approach but does it well. It has the lowest latency in many regions due to Google's network, and its API is the most straightforward to use programmatically. All three support DNS SEC, though implementation details vary. They also all offer private DNS zones, but with different approaches to network integration. Traffic routing capabilities. Traffic routing is where these services really differentiate themselves. Let me explain each routing type and when you'd use it. Simple routing is just basic DNS. One domain points to one or more IP addresses. Weighted routing lets you split traffic by percentages, perfect for canary deployments. Latency-based routing sends users to the lowest latency endpoint, while geolocation routing is based on the user's geographic location. Failover routing is crucial for disaster recovery. You designate primary and secondary resources, and traffic automatically fails over if health checks fail. Multi-value answer routing returns multiple healthy IP addresses, letting the client choose. Route 53's geoproximity routing is unique. It lets you shift traffic between resources based on geographic location and a bias value. This is powerful for gradually shifting traffic between regions. The diagram shows how these work together. Notice how health checks are integral to most routing policies. Unhealthy endpoints are automatically removed from responses. Pricing analysis. Let's talk about costs, often the deciding factor for many organizations. DNS pricing has several components, and understanding them is crucial for budgeting. All three providers charge for hosted zones monthly. Route 53 and Cloud DNS charge 50 cents per zone, while Azure charges 50 cents for the first 25 zones, then 10 cents per additional zone. This makes Azure more economical for organizations with many domains. Query pricing is where it gets interesting. They all use tiered pricing where the per million query cost decreases with volume. Route 53 starts at 40 cents per million, Azure at 50 cents, and Cloud DNS at 40 cents. But these rates drop significantly at higher volumes. The real costs often come from additional features. Route 53 health checks are 50 cents to 75 cents per health check per month. Traffic policies add extra costs. Azure Traffic Manager has its own pricing. These can add up quickly for complex deployments. The example shows a typical medium-scale deployment cost breakdown. Notice how the base DNS costs are minimal, but features like health checking can dominate the bill. Use case recommendations. After working with all three services, here are my recommendations for different scenarios. For AWS-centric organizations, Route 53 is the obvious choice. Its deep integration with AWS services, sophisticated routing policies, and mature feature set make it ideal for complex AWS deployments. Use it if you need advanced traffic management or are already invested in AWS. Choose Azure DNS if you're running workloads on Azure or in a hybrid environment. Its Resource Manager integration and private endpoint support are excellent. Combined with Traffic Manager, it rivals Route 53's capabilities while maintaining Azure's management paradigm. Google Cloud DNS is perfect for organizations that want simple, reliable DNS without complexity. Its performance is excellent, the API is clean, and it's very cost-effective. If you don't need fancy routing policies, it's an excellent choice even for multi-cloud deployments. For multi-cloud architectures, consider using Route 53 as your primary DNS with its advanced routing, while using Azure DNS or Cloud DNS for internal resolution within those clouds. Conclusion and best practices. As we wrap up, let me share some best practices that apply regardless of which service you choose. First, always use multiple DNS providers for critical domains. DNS is too important to have a single point of failure. You can use one as primary and another as secondary, synchronizing records between them. Implement health checks comprehensively. They're not expensive compared to the cost of downtime. Monitor not just endpoint availability but also application health. Use infrastructure as code for DNS management. All three services have excellent Terraform providers. This ensures consistency and enables proper change control. Plan your DNS architecture carefully. Consider using separate zones for production and non-production environments. Use private zones for internal services to improve security. Finally, monitor your DNS query patterns and costs. Set up alerts for unusual query volumes which might indicate DDoS attacks or misconfigurations. Thank you for joining me in this comparison. DNS might seem like a simple service, but choosing the right provider and configuration can significantly impact your application's performance and reliability. Please consider subscribing to the channel. I would greatly appreciate it.